The second experiment that we are going to see is how to interface a temperature sensor to the ARM processor. The temperature sensor is a simple device that detects the external temperature and gives us the corresponding digital value. So this is something similar to an analog to digital converter where the temperature sensor detects the external temperature, which is an analog value, and it converts into a corresponding digital value. So talking about the components that we are going to use in this experiment. So if we take the hardware, the first thing that we'll be using is the LM35 temperature sensor. The second thing is your ARM, which is ARM LPC1343. So only these two hardware components we are going to use. We are going to interface the temperature sensor to the ARM processor. And coming to the software part, we are going to use the CooCox IDE where we will build our project. And from the CooCox IDE, we will try to generate the hex file. So not only in CooCox IDE, in any of the softwares, once the build is successful, a hex file will be generated. Now, since we are physically not able to do our labs, we are going to perform the hardware part using the Proteus software. So using this hex file, if I bring this hex file or if I dump this hex code into the hardware in the Proteus software, we can actually bring about the same output that we do during our physical lab classes. Now let us see how to do that. So we will first start with the programming part. So if you see the first statement, it is hash include lcd.h. So this is a library file that we add, and why we have LCD here is the analog to digital converted value is going to be viewed using some output device. So we need some device where we can view the required values. We are going to use a LCD for that. The next line is void ADC experiment. This is like a predefined command. So if I mention the term or if I mention the command ADC experiment, my CooCox will understand that it has to proceed or it has to do the analog to digital conversion process. So if you do this in a traditional normal C programming, it almost takes up to 20 lines of code. But when we use CooCox IDE, we can easily use these type of commands to program your ARM processor. And by just mentioning a single command, we can make the processor understand what are the required steps to be done internally. So this will enable the total analog to digital conversion process. And if I call something called as the ADC experiment, the analog to digital conversion process will start to take place. The next one is the main loop. Now inside this we have the receiver interrupt, which is the first line. Receiver interrupt is nothing but take the temperature sensor. The function of the temperature sensor is to detect the environmental temperature and give a corresponding digital value of that. That is why we call the temperature sensor to be an ADC. It is an analog to digital converter. Now, for example, now my temperature is 10 degrees Celsius. The corresponding digital value will be given. But if the temperature changes to 12 degrees Celsius also, the corresponding value has to be displayed on my LCD. So for every change in temperature, that change is going to be taken as an interrupt and every change will be recognized and the corresponding digital value will be given. So for every small change in temperature, the processor will consider it to be an interrupt and that will be processed by the ADC and the corresponding digital value will be displayed. The next two lines is for displaying on the LCD. So to begin with the LCD, we need to initialize the LCD first, and in the next line, I need to print the display or print whatever we have to print on the LCD. The LCD we are using is the 16x2 LCD. 16x2 is nothing but I'll be having two lines where in each line I can display 16 characters in total. So if you see here for line 1, I want to display the value is. So in the LCD in line 1, it will display the value is and the corresponding value that the temperature sensor detects will be displayed over there. So that is the function of put string. It is similar to a printf statement that we have in C programming. The next is once again we call the function ADC experiment because every time a temperature change is detected, the total process has to take place. That's why we have ADC experiment. And while of 1 means it is an infinite loop. So the total execution goes on again and again for every change of temperature. This is about the programming. Now we know how to program it using the CooCox IDE. So The steps are similar to what we did in the LCD program, the first experiment. So once you do the required steps, we know that a main.c file will be created here. So in the blank window that appears, we will type the program and we build it. So here we have the build option. So we will build the program, and if there are no errors, we will get a message as build successful. Once we successfully build our program or every program, a hex file will be generated for each and every program. So if you go to the folder where you saved your program, initially you would have given a folder or a path where you are saving your project. So if you go to that path and check, a hex file, a file of type .hex, this will be generated. This is very important because using this only we can perform the hardware part using the Proteus software. So for this temperature sensor experiment, a hex file will be generated. So have that as such. Now coming to the hardware connections. So this is your temperature sensor. So this is the LM35 temperature sensor, and this is your ARM processor. It is LPC 1343 series. You can see the series number which is mentioned here. The hardware connections are quite simple. To pin number 1 of LM35, we connect the supply, which is VCC. Pin number 2 is the actual output pin. So since this is similar to ADC, we connect this to AD1. If you see here, this pin is AD1. We connect the output pin of temperature sensor to the AD1 pin of the ARM processor, and pin number 3 is grounded. So only 3 connections for interfacing a temperature sensor with your ARM processor. After this, as similar to how we did in the first experiment of flashing the LED, right click on the ARM processor, you have to give edit project and you have to dump the hex file into this processor. After that, you can simulate the file using the play button which is present at the bottom here. So we will see how to do the simulation. So we have given the hardware connections, I have stored the hex file here, everything is done. Now let me click on this play button. So we can see that a voltage value is displayed here. So I have connected a probe. We can connect a probe using this option. This one. So if you click on probe mode, there are 3 options: voltage, current and tape. Click on voltage and place the probe over this AD1 pin. Now we will try to vary the temperature and check whether there is a variation in the voltage value. So I'm increasing the voltage and we can see that the corresponding voltage is also getting increased. I'm decreasing the temperature and we can see that the voltage level is also getting decreased. So this is how we interface a temperature sensor to ARM processor. If we increase or decrease the temperature value, a corresponding change in the voltage can be detected. So this can be connected in real time. You can do it physically in hardware and check. This is used to monitor the external temperature. So this is about how to interface a temperature sensor to an ARM processor. Thank you.